It all starts with one idea. Have you ever wondered how today's top CEOs, business leaders, and people who work for the most innovative companies in the world found success? Join host George Davison as he explores the innovators that are shaping tomorrow's world today.
Well, welcome to another edition of The Innovators. And today we have a new guest, and she's so exciting to talk to. I'm going to introduce you to Dr. Kathy McCarthy, and she's from Oak Ridge National Lab. Her title is officially the Associate Laboratory Director of Fusion, Fission, Energy, and Science. Well, that's a mouthful.
It is a mouthful.
Well, welcome, Kathy.
Thank you. Happy to be here.
Well, thank you for making that trip out here. You know, we have so many people in this audience that are going to be curious about how you've achieved what you've done in your life, and I'm hoping you'll share what you can with us today.
Yeah, I'd be happy to do that.
Okay. Well, then how about we start with some of the basics? A lot of the people out here probably won't know what Oak Ridge National Lab is and what you do out there, so could you share that with us?
Yeah, Oak Ridge National Laboratory is one of the Department of Energy national labs, and the role of the national labs is to do science and technology that eventually is applied in industry, that ultimately helps industry, solves big problems, big challenges.
Mm-hmm. So how could I engage a lab like that? If am I a business? Am I an individual? How do I bring problems to you?
So typically the way that works is connection with one of our scientists and engineers, or potentially connections with one of our managers. And we go out and we'll talk at conferences and things like that. Mm-hmm. So it's that initial discussion, working through, well, how could the lab help, put a plan together, go through the appropriate approvals, and move forward from there. And from our perspective, working with industry is key. Now, that hasn't necessarily been historically what the national labs have done. But for us to be able to take this science that we do and see it actually applied in industry, that's a really important part of what we're doing now.
Very, very good. Yeah, because you do want it to convert into something, right?
Yes.
So, but what's interesting maybe for the audience to know is that chemistry class or that lab class that you're doing in middle, or let's say high school, maybe college. So there's a place to go, right?
You know, it's funny because I remember in chemistry class in high school, when we had to memorize the periodic chart of elements, like why would I have to do that?
Yeah.
And it's funny now because, well, not so much in my everyday job as a manager, but when I was still doing technical work and I still need to understand all that, I actually use those things. And I don't think I really appreciated that at the time.
Right. Those basic building blocks, they're kind of putting them in our head and we're saying, why? Why? You know, and but you know, our teachers they're guiding us. They know, they kind of know we need certain things, and those basic building blocks. If you're going to be in the lab business, you better know your periodic chart is what I think I just heard.
Big part of it, yes.
All right. So let's talk about Oak Ridge National Lab, and can we frame how important innovation would be at your organization? Like, how does that work?
Innovation is key because the problems that we have to solve, they're challenging problems. The reason a national lab would take something on is because you need a combination of unique facilities, unique capabilities, people looking at a problem from all different backgrounds to figure out how to solve it. And like I said, these are very challenging. This isn't your cookie cutter sort of thing. That's why you come to a national laboratory. So innovation is key. I
see. So people who think innovatively would be your most precious natural resource. Is that fair to say?
Yeah, I would agree with that. And it's sometimes the innovation happens only because you've got this set of people with different backgrounds. Maybe one individually isn't the most innovative person, but they'll ask a question that makes you think about things in a different way. Yeah. That's why that whole concept of diversity is important. Diversity from how you grew up, where you're from, your technical background, not technical background, because sometimes the hardest questions come from the non-technical people.
You know, that is so true, because that happens in our world over here, too. And then the technical people have to say, What? You don't understand how that... And then they have to say it out loud. And then all of a sudden, the whistles and bells start to go off. We've seen that as well.
No, it's true.
Good stuff. So I'm going to say it again because Associate Laboratory Director of Fission, Energy, and Science. I think that's one of the biggest titles I've ever heard in my life. And so for our audience, can you walk us through what does a day in the life of that look like?
My job is really exciting. I really do have the greatest job. What we look at, if you look at the fission industry, the fission energy industry, we have operating reactors. But we're looking at how do we make them operate more efficiently, right? Economics is key. What are the next things we need to do so that carbon-free nuclear power can penetrate markets that it couldn't necessarily with the conventional big reactors that exist now? They're important, but we need to do more. And then you bring fusion into that, and this is a group of people, and my graduate work was in fusion, so that's I've kind of done, not kind of, I've done about half my career in fusion and half in fission. The fusion side is the very creative side, right? Fusion reactors exist in the laboratory. They don't produce economical energy. And if you think about, you've got the temperature of 10 times the temperature of the sun, 150 million degrees centigrade here, and right here I have 500 or 600 degrees centigrade. How do you do that? And so we look at ways to do that, and that combination of fission energy grounded in, well, ultimately, here's what you need to do, and fusion energy, let's think out of the box on how to solve these hard problems. You put those together, and it benefits both. So I've got the most exciting job in the world because I get to bring all those people together.
That's pretty interesting. I don't know how you figured that out, like how to navigate your fission and fusion world to create this interesting space. But I imagine you're going to need more people in that space in the future, right?
Oh, we are always looking for more people. Absolutely.
So let's kind of go back on a bit more of your personal journey as to how you got here, because we're looking for, let's say, younger people coming up, right? So let's talk about your journey. How did you become interested in nuclear energy?
I was actually going to major in music. I played clarinet in high school. I enjoyed it very much. I grew up in Livermore, California, in the San Francisco Bay Area. My parents both worked at Livermore National Laboratory. My mother very early before she had children, and my father the whole time through when I was halfway through my freshman year in high school. So I grew up in this environment. My parents would have epic parties, physicists and engineers, and once we got old enough and weren't being sent next door to the neighbors during the parties, we got to stay up and talk with people. So I kind of grew up in that environment. I was good at math and science, and I made a last-minute decision, really last-minute, my senior year in high school, to actually go into engineering instead of music. I still love music, don't get me wrong.
Sure.
But I kind of did the more practical thing, and my parents never pushed me in either direction, because if they had pushed me, for example, towards engineering, I guarantee you I would be a music major right now, which is fine and good. But I think ultimately I made the right choice, and specifically nuclear. So I decided in my senior year, all right, I really like math and science, but I don't want to be a mathematician. I don't want to be a physicist. But engineering, that kind of brings in all those different pieces. And I had a high school physics teacher, Mr. Wells, Malcolm Wells. I still remember him. I actually looked up recently, and he's not alive anymore. That was a little while ago when I was in high school. But Mr. Wells, this was the year that 3 Mile Island happened. So now you can figure out how old I am. I was not a child prodigy. So Mr. Wells would talk about the 3 Mile Island incident as it was unfolding, and it was very much from the perspective of, what could be happening and helping us to sort of think about these things. And he was also very much of the mind that nuclear energy is important. Nuclear energy is really key to reducing carbon, mitigating climate change, even back then, all those sorts of things. So I thought, okay, engineering, nuclear, I'll try that. And my first day at University of Arizona, I was enrolled in the nuclear engineering program.
Isn't that interesting? So your discussion with other people that found a interesting inspired you and started getting you on a path, a direction. All right. So we have all these, let's say, high schoolers out there right now. We need them to start interacting with people like yourself and other mentor types of folks. Could you tell me what in your background is what you drew upon that led you to your current position?
It's an interesting question. One of the things, as we're looking at how do we attract people into STEM, and the way specifically that we sell engineering doesn't typically appeal to, and I'll talk about women because I've looked at this quite a bit because it's one of the things I've tried to help with, and engineering tends to lag in STEM in terms of women and underrepresented minorities more so than other fields. So we tend to sell engineering as hands-on sort of things, fixing things, building bridges, building buildings, and that kind of thing. And that works for a lot of people. And actually, that kind of works for me because one of the things I liked early on was putting things together. My parents used to, there was a local theater company, and my parents would be in the shows over there, and us kids would be kind of waiting while they did their rehearsals, and we weren't interested in watching. But there were boards and hammers and nails and things like that, and I liked putting those things together. I just liked doing that. My parents got me one year a Lego set, which then they built on. I have this amazing Lego set, and I used to make these cars. It had a little engine. I could do all the, not an engine, a battery and cogs. So for me, it was playing with that sort of thing, and I really liked that hands-on thing. On the other hand, if we're really looking at appealing to a broad audience, the other way that we need to sell engineering is, in general, women tend to like to go into fields where they can help people. Engineering helps people every day, and we don't talk about that enough.
Sure does.
So it was really, a combination of those sorts of things. I have this great erector set, all these things that I actually saved and brought out when I had kids, and I'll bring them out for my grandchildren. And it was nurturing that kind of thing, and it graduated into, my parents were very clever, right? It wasn't we really think you should do this, but rather let's put these things in front of you that pique your interest. So I remember one year I got a Heath kit, and I got to put together a radio. So this is when I'd graduated to soldering and things like that. So all of those sorts of things helped me. It's not necessarily something that would help everyone, but that's part of the reason I think why I am where I am.
So exposure to STEM type activities, and then letting you have the freedom to choose and play and create what you wanted to create, right?
Well, and you talked about innovation, so here's another thing. I like to fish. I've always liked to fish. My parents would take us fishing. I've got 2 sisters, no brothers, so us 3 girls, and 2 of us really like fishing. My older sister doesn't like it at all. But we would catch grasshoppers. And grasshoppers are good bait for fishing, right? Worms are too, but they're pretty easy to catch. So Dad said, why don't you invent a container for grasshoppers so that, it could help you to get it out and be able to put it on a hook. I worked on that. It was actually really never very good and never really got built. But my parents encouraged that kind of thing.
Right, that kind of thinking of, well, there's a challenge. Can you figure it out? Right? Yeah, that kind of, there was a lot of that in my brothers and my upbringing as well, and a lot of science, a lot of go explore, go figure it out. Around here, we refer to it as go fail your way forward. Learn how to pick yourself back up off the floor. But going back, you've mentioned some of the background of your parents. In general, did you have any other mentors that are like sticking out in your mind that helped to shape you?
Yeah, and really as I look through my career, so I got to University of Arizona, and one of the professors there, I think he was actually emeritus even at the time that I went there, was Norman Hilberry. Dr. Hilberry was part of the Chicago Pile experiment, one of the very early demonstrations that led to practical applied fission energy. Dr. Hilberry took me under his wing. And he would talk with me, and he would encourage me that you should think about graduate school, you should do this, you should do that. So that was absolutely true from a school, education perspective. And my parents always continued to encourage me, and my uncle as well. My uncle at one point was Deputy Undersecretary for Caspar Weinberger. So we got to tour, we got to go through Caspar Weinberger's office. He wasn't there, of course, and see those sorts of things. But Uncle Larry I still call him Uncle Larry, even
Sure.
though he's 80-something now. But Uncle Larry was also somebody I talked to quite a bit about, what I should do and what are the opportunities. So I've been really lucky because I haven't really had to. I've had a lot of role models, a lot of people who really helped me.
That's a blessing. So maybe that's a good spot to kind of put a placeholder on. Let's imagine for a moment that you didn't have those mentors. Being a strong-minded young woman, what do you think you would have done?
That is a really good question. I don't know. I might have come this direction anyway. I have to tell you, I have not ever been one of those super organized planner people. Here's my 1 year, 5 year, 10 year. I've kind of been a little bit of a, not a pinball necessarily, but certain directions that I've gone, they've kind of fallen into my lap. I'll give you an example. Graduate school. I was looking at, should I go into nuclear engineering or should I go into nuclear medicine? And I looked into both and decided, I got to go to school too long for nuclear medicine. I'll do a PhD in nuclear engineering. By the way, that's probably not a good judgment on my. I think they're about the same amount of time, but that's okay. But I think all of us look for, one of the things I try and do now, because I recognize I was lucky. I had all that. I had that support system. I do try and go out and talk at the schools and trying to explain to elementary school children how nuclear fission works. That's like one of the hardest things I've ever done.
Oh, I can't imagine.
I go and I'll talk at universities. I'll talk at different conferences focused on different groups of people. I think we all really need to do that. And it's interesting because I have had a lot of women, for example, come to me and say, I really appreciate you did this. You came and talked with us because I do look at you as a role model, which honestly I never really thought of myself like that.
Well, but it's look at it from where they're coming from. If they don't have mentors, they don't have, let's say, 2 parents at home. Some of them have no parents, and that's kind of part of our audience, right? We have these kids in school; they're directionless. They don't know what to do. Really, some of them don't have a caring hand to help guide them, right? Even though some people do have caring hands, I'll figure it out myself, because we usually, like you said earlier, if they said pick one direction or the other, you'd pick the one they tell you not to take. So we are rebellious, but if you don't have anyone helping along the way, you do have your teachers, right? So, maybe, which has come up in other discussions as to if you're a young person and you need some guidance, that's a good place to turn.
Well, and one of the things that several national laboratories do, and by the way, the first 25 years of my career were at Idaho National Laboratory. I know it very, very well. One of the things they did was the high school teachers workshop. They would bring in high school teachers from all over the United States. I can't remember how many states they ended up covering. They also had some foreign teachers, and they basically would teach them about nuclear science and engineering, nuclear science and technology, and give them the tools to be able to teach it when they went back home. Things like, here's a Geiger counter. Here's how it works. You can put it up against FiestaWare, and FiestaWare, you'll actually get a reading, right?
Right.
But the teachers, they need the tools to be able to teach, and I think that was a great thing that Idaho National Laboratory did, and that other national laboratories have as well, this sort of outreach, and Oak Ridge National Laboratory does outreach as well. I think it's part of our job to help with that.
I'm glad to hear you say that. Invention Land Institute, that is a challenge with that organization. It's, for example, 3D printing is a big.
Oh gosh, I love 3D printing.
Same. I mean, it's just. I remember when we got our first 3D printer, it was a huge machine, made little tiny parts, really fragile, and now they make a machine this big, and you can really hit this stuff, and it's strong. But if we don't have teachers that are intrigued with 3D printing, right, they're not taught those skill sets later in life. They can't teach our youth today. But, kids can help drive it. I've seen some of these young kids ask, I want to learn how to do 3D printing. And teachers are good at picking up the phone and asking questions. And so, I'd say without family being there and guiding and pushing you in the right direction, we need to find ways of, and that's part of what this is all about, right? How do we give knowledge and mentorship to as many young people as possible so they don't feel lost? Right? Do you have any other suggestions on that, on how to not feel lost? Or I'll just move on if you think we're good there.
I think part of it, and you alluded to this earlier, it is really important that people understand that it's okay to fail. And I worry a bit that as a society, and even in the research that we do for the Department of Energy, there is the expectation that you're going to get it right every time. And if you get it right every time, you're not thinking out of the box enough. So we have to help kids to understand it's okay to fail.
Yes. It's hard for a teacher to say that, right?
I know. Maybe not fail the test, but yeah.
Right. All right. Well, let's keep moving then. We're going to start touching on advice that maybe education and that kind of thing played in your life. But if you could go back in time and you could do one thing over again in high school or maybe in your early college years, what would it be and why?
I think...
And I'm asking in terms of like career development, like leading you in a direction.
Well, I hate to say this out loud, but maybe listen to my parents more, but I'm not sure that anybody ever really does that. But I think that seeking out adults and asking them for advice, I think that's a really good thing. And I didn't do that all that much. I was kind of lucky again because I had, a support group around me. But also really taking advantage of opportunities that come up in the community to learn things, right? To go to things. And again, one of the things I was really lucky about, I remember when Livermore National Lab had an open house, which they didn't typically do, right? It's a weapons laboratory. And one of the things they had was this simulator you could play on that was kind of like a precursor to SimCity. That was a long, long time ago. I remember that. That was cool, and that was really inspiring, going there and seeing that. So take advantage of those sorts of things. National Labs do open houses periodically. So, butterfly wings actually don't have pigment. It's the color is made by the reflection of the light. If it actually had pigment, they'd be too heavy to fly. So and this is again back when I was in Idaho, we've done similar, well, not since COVID, and I've only been at Oak Ridge since COVID, but we've done similar things at Oak Ridge. Historically, you bring people in, bring kids in, have them look through these microscopes and explain those kinds of things that are super interesting. We need to help them understand how exciting it is in the world of science.
That gets the imagination going, right? Very, very important, very big. So how important are STEM-based classes for someone interested in pursuing a career in your field?
They're very important. Now, one of the things I really liked about nuclear engineering is it absolutely is you need to have a good math basis, but you also have to have a good physics basis. It's very, very heavy in physics. So, well, I'll tell you something maybe I should have done back when I was younger. There were times when I crammed for a test, right? When you cram for a test, I'll admit it, you actually don't learn things as well as when you actually kind of learn it all along. Don't cram for tests. Actually pay attention to it. But that foundation is really key. And I did find myself in times in college, I'm in a class thinking, probably should have known this, and had to kind of go back and learn it. So I would say do pay attention to those things.
It's so funny to hear you say don't cram for tests. There's a young man who's in our life now, and he's a very intelligent young man. And he scores very well on his tests, every one of them. But what he learned was that I don't like bad stress, is how he said it. And I said, what is bad stress? Well, bad stress is when I put things off so much that I get down to the final hours and now I'm trying to put all this information in my head. He said, there's good stress. And good stress is I know I have that test coming. It's in 10 days. So I put the burden on myself to take a piece of that on Monday, another piece on Tuesday. By the time I get 3 days away from that test, I go take the test. I'm not in stress. I pre-stress, and then I have no stress. And I thought, it's a really good way to think about it, right?
Mm-hmm.
Get ahead of it, But if no one tells you that, and actually his counselor is the one who taught him that, and I thought, darn, I wish I had a counselor like that.
Hey, look, I still even now sometimes mess up on that one, right? So yeah, do learn things, don't cram things.
Mm-hmm. Well said. Okay, so let's see here. So knowing what you know now, what advice would you give a person interested in entering into your industry today?
Ask questions. My industry is so broad. What is it that you like to do? Are you interested in the current fleet of fission reactors, keeping them going? And that's not as easy as it sounds. Think about having to survive very, very cold weather, things like that. There's all different aspects of the current fleet. Are you interested in the next generation? Do you like to look at ways to do things better? If that's the case, maybe you want to kind of go the direction more of research, and that would put you in a certain direction in terms of your classes and things. So, and I think this is true for any field. There's so many different options, so many different paths you can pursue. So you're kind of interested in something, well, check into it, ask questions. If you have an opportunity, a lot of the labs do high school internships for high school kids. Certainly, when you're an undergraduate, do an internship. It can be at private industry. It can be at a national lab. That'll tell you really what the day-to-day life is for somebody like me, or back when I was a researcher and actually did things.
All right. So what classes, though, would you suggest? Do you have any suggestions there?
Are you talking, well, when you're in high school, through high school?
High school.
So you do, as you get to high school, you do have opportunities. For example, take calculus. Mm-hmm. It's not a required class. I think I like things like calculus. To me, it's black and white, and here's the answer, which is one of the reasons why I'm an engineer, not a philosopher. So that whole not having a real answer kind of makes me a little bit crazy. Mm-hmm. So math classes are really important. Physics classes are really important, but also don't ignore the other side of things, because engaging your creative mind. So I think for me, music helped me with my engineering.
Yes.
Because there's a lot of similarities. Mm-hmm. So try to do both.
There's a lot of engineering in music.
Yes, there is.
So, but probably the creatives in the music side don't want to think of it that way.
No, and actually to take the engineering piece of it, read the music, I can play the music and turn it into music, that takes the creative side, right? Mm-hmm. Your other brain, your other side. I always forget which is left, right, but yeah.
All right. So let's chat for a moment about, we have all these different people in our country and all different walks of life, right? Do you think any and all of them can be successful?
Yes. I absolutely believe that. One of the things, it's really fascinating if you look at, so I am the granddaughter of immigrants. I'm not the person that can trace my heritage to the Mayflower. We haven't been here that long. Mm-hmm. But my mother's parents came from Spain, came from very poor family. They worked in Hawaii in the sugarcane fields first, and then came up to the San Francisco Bay Area. But for them, education was really important, and they always emphasized it. So, you look at now, my mother got a degree from UC Berkeley. Her parents actually, my grandfather did take some classes at UC Berkeley. And now you look, and I have a PhD in nuclear engineering. Anybody can be successful.
It sounds like you believe it wholeheartedly, and education played a very important role in your family.
Yep.
Yeah. So that's a way that you helped yourself or helped your family to move in a direction that you wanted to seek?
For me, again, there was always that emphasis on education, and I think this is one of the things that a lot of kids growing up don't have that. Mm-hmm. So how do we help them to see that, to get that understanding that, and by the way, college isn't for everyone. We need people that do things other than go to college and do what I do. Mm-hmm. But I think that there's that whole untapped segment of kids that could be so good at this, but we're not reaching them. So what do? One of the things that we're having a lot of conversations at Oak Ridge National Laboratory, and you can find this across the United States, is how do we help people into this? How do we get that diverse group involved in what we do? And by the way, Oak Ridge National Laboratory does an amazing variety of things. I'm just one of a small part of what they do. We do pretty much everything, biology, all sorts of things. So there's kind of something for everyone. So we're talking at the laboratory about programs that can help with that pipeline and engaging some of these communities that don't even hear about these opportunities, because that's what's going to have to happen in order to really change things.
Right, to open it up.
Yeah.
Right, bring in different thoughts, different kind of folks. But I'm really happy you shared some of the background, where your family's from. I mean, I think it means something to look back and say, yeah, we sweat and we worked hard and it sounded like they were working in fields. And,
yeah, literally.
And we got our hands dirty. It's all right to get your hands dirty. That's
yes.
part of the process of advancing, if you want to. Or you can keep doing that if that's the kind of work you like. But sharing that story is, I think it's really important people see that. Because sometimes people, like I'll go to some of these seminars, and sometimes I'm teaching some of these seminars, and it's terrible to hear. Like even teachers in some of the school districts that are, they're like, oh, our kids can't do this kind of stuff, and we don't have access, and I think to myself, well, I see school districts at the best level, and I see it at the worst level, and each of them have their strengths and each of them have their weaknesses, Kids who have everything going for them, they have a lot of problems coming usually. Yep. You see a lot of drugs, you see a lot of problems because they're directionless as well. And then you have kids who have nothing, and I think one of the benefits there is it's like failure way forward, right? You have nothing to lose. Try again, or keep going, keep working. And they just, those two different worlds don't know what the strengths and weaknesses are of those two worlds. But we need them all, right, to get to where we're trying to go. So thank you for that thinking on your part. So anyone can be successful is what we just concluded.
Absolutely. Right? And success means all different things. Again,
right.
I don't think everybody should be me.
Right.
What I've done. That's just what worked for me.
Success is a broad word.
Yeah.
To some people it's money. To others it's making a contribution to society. Or I just made the most successful cookie batch I ever made in my life, right? So there you go.
Which is important.
Yeah, it is. I like good cookies.
Me too. Actually, I like the batter better than the cooked ones. But
darn it, so do I.
Yeah.
Look out. If you leave that bowl of good stuff sitting there, it won't be that way when you get back. All right, so can you talk a little bit about what you think the next big innovation in the nuclear industry is going to be, and how can students in school begin to prepare for that innovation and beyond?
I'm going to talk about fusion as the next big innovation in nuclear, right? Okay. Both nuclear processes, both fission and fusion. And there are absolutely challenges in fission too. But I think probably a lot of the other people that you're talking with will talk about that. So I'm going to talk about fusion. What we're doing in fusion is bring a star to Earth. We talk about it like that, and you think about what does that mean and what does that take, and specifics. One of the things I would say, understanding materials, and actually this is true not just for fusion, but for almost any industry. When you get a failure, you can almost always, or quite often, tie it to some failure in materials, and so developing materials is important. So I think that the next big innovation that is truly needed, and we're working on this, is materials that can withstand extreme environments. And it's not limited to fusion, right? We talk about this when we put spaceships into, to go wherever they're going to go. They have to withstand heat, things like that. So I think that that's a really, really important area. And of course, tied into all of this is computers. And that's another area that is so much, when we talk about quantum computing, and don't ask me to explain it, but those sorts of innovations are key. Yes.
So I think when you say material science, maybe the idea behind that would be how to have things held together, even though you have extreme temperatures on both sides of the material in the middle. right? So we're trying to control this temperature chasm, so to speak, right?
Yeah, and keep that really, really hot away from something that can't withstand the really, really hot.
Yes. So that's an interesting field. So let's say I like that idea. I'm listening to this. How could I start to think that maybe I could get in there and help solve that problem, and that material science problem?
So it's looking at, I would, first of all, you can do a lot of looking on the internet. Be careful what you read. Not everything is right. Go to the National Lab websites, because they'll talk about the sorts of things that, the sorts of challenges that exist. But if you're going into college, and this is one of the things, I have a niece who is just finishing up a mechanical engineering degree at University of Arizona, and she and I talk quite a bit. We talked about graduate school, and I talked about material science for the reason that I said earlier, where there's so many things that you can apply it to. So first of all, that good basic education. But then when you start talking about, when you've got a fusion reactor and it sees neutrons, energetic neutrons, more than from a fission reactor, the surface gets bombarded by lots and lots of neutrons, so much so that it changes the structure of the material. And we have to understand how that what is the behavior once it's changed, because you still need to have it maintain its integrity. So maybe you're interested in things at an atomistic level. I want to be able to actually model atoms, which, by the way, our supercomputers allow us to do now, right? And how they move and how all these things interact, so that's a direction that you could go. But I can't underestimate the importance of internships. Connect with people, reach out to, find a high school teacher. Like I had Mr. Wells. I had my parents too, and all the people at the really great parties that my parents held. But talk to them and ask them questions, because they actually really like it.
Right. Yeah, that's. I think we need to go back for just a moment, though, to make sure that our audience understands. We talk about material science because we know what that is.
What does that mean?
What does material science mean?
So think about the surface of this table, and this is what we see. We actually enlarge it so that we're looking at a size, a part of it on the order of think about the width of your hair, the average hair, right? They're different. You go down and look at things at that level, they look totally different. So I see this flat surface, and I see that it's white. Well, if you look at it with powerful microscopes, that's not what you see. You'll actually see imperfections. You'll see little holes. You'll see, this is a composite, so it's got different materials, so I'll see the different elements. And understanding how those move, that's what makes this a table that works, or a table that, if I set something down on it, creates a stress that causes a problem. Understood.
So what we're talking about then is, when you, let's say, look at something through a microscope and you can see it down at the very, very, very small level, what are these particles? How do they all come together? How do they create some kind of a surface, right? And then there are thousands and thousands of different types of materials, and how can you bring them together? How can you combine them? How can you integrate one material that doesn't belong with another? Can that be figured out?
Yep.
So let's say that the material science area, knowing that it's an emerging area, are there particular places that I can learn about that, accessed by my school computer?
Absolutely. You will find various websites that, and again, I would start at the National Laboratory websites, and the links are perhaps a bit more, you can count on them a bit more, to be accurate. Thank you, reliable was the word I was looking at. You can certainly start there. The other thing, too, is kind of depending on what level you are, you can find some really interesting podcasts out there. For example, MIT has a series. They do a lot of their classes as podcasts. You can just go and you can access them for free.
That's right.
And I think doing things like that can help quite a bit. So it sort of depends on the level that you're at.
Right. That's a good idea. So one of the suggestions would be get a hold of some of the labs, or one of the more technically oriented schools like an MIT, and see what they're offering online, that you can just grab onto it and listen and see if it inspires you in some way.
Absolutely.
All right, so let's go in a totally different direction now. We're going to move on to the world of big education, politics, government, that kind of thing, where we're going to pretend for a moment that we have our educator people that are guiding the ship on what we should be teaching our young people. If we were able to communicate with them directly, based on your background and all the work you've done over all these years, if we could talk to them directly, what would you suggest to them as ideas on how to best teach our kids?
That is a really tough one, because different people learn in different ways. I'm actually going to use as an example of, I think, a really good way to teach is the whole Montessori process. My husband and I sent our kids to a Montessori school through 6th grade. And the reason why I say Montessori is because they do it both in a hands-on sense. So when they were teaching our kids about numbers, you actually had, I can't remember what they call it now, manipulable, I can't remember, things that you touch and move that show you this is how much 1 is, 10 is, 100, right, starting at the real basics. But then they would also have kids looking at things from the book perspective. Different kids learn in different ways. Don't assume everybody learns the same way. That's honestly the number one.
Yes.
But Montessori, the other thing that they did is our kids, so early on, before kids can write, they were able to write book reports by parents would come in, and I did this, and volunteer to write what they said. And we wrote these stories for them, right, to help kids get into that whole mindset. And I there's so many other good examples with the approach that Montessori takes, but I think the big message is different people learn differently.
Yes.
And the super good teachers are...
Get it.
Yeah, they do. I think we need to pay our teachers more. I will just say that, because they're so important.
They really are.
So there, I had to get the political thing in there, too.
Well, Kathy, I can't thank you enough for coming in here today and sharing your wisdom with us.
Well, thank you. I really appreciate it. I enjoyed the conversation.
For more information about the innovations and ideas changing tomorrow's world, tune into Tomorrow's World Today, now streaming on Science and Discovery, or visit tomorrowsworldtoday.com. For more information about the innovations and ideas changing tomorrow's world, tune into Tomorrow's World Today, now streaming on Science and Discovery, or visit tomorrowsworldtoday.com.